Okay, now that we're done with our set theory unit, we're going to move on to probability. So here's the outline for this unit. So today we have our double, so we're starting with that. So we're going to do a lesson on odds and probability here. And then for the second hour, you guys are doing just work and practice on that, and that's listed at the bottom of this lesson. And I'm going to follow up with you guys about your project. Tomorrow, you guys will do lesson number 2. Wednesday, you'll do lesson number 3. Thursday, you'll do a work block. Friday, we'll do some more logic puzzles. And then next week, because again, we have Monday doubles, the first hour is going to be review on all of this, and then that second hour is going to be that quiz. So you guys can ask questions and whatever in that first block, and then you guys can write the quiz in the second block. Then you'll review. I'll make sure those quizzes are marked, give them back so you guys can review those, do some last review on whatever you might be struggling with, and then the test will be on Wednesday, September 30th. Okay, so to start today's lesson, when we talk about odds and probability, I think we're all familiar with these things, hopefully. You've definitely been doing probabilities in math for probably since like grade 7 or 8. Probably haven't seen a lot of odds. I think in general English, those two words are interchangeable, but they're not in math, so we're going to talk about why. So, probability expresses the likelihood of a particular event happening. It's given by the ratio of favorable outcomes to the size of the sample space. So, we write it as the number of favorable events over there should have been total number of events. So the probability of some event is the number of favorable events divided by the number of total events. So generally this is going to be a fraction, a decimal, or a percent, and it's going to be between 0 and 1. So if we talk about like rolling a 2 on a die, we'd have a 1 out of 6 probability, and we could represent that fraction as a percent or a decimal as well. Okay, the probability of an impossible event is going to be 0 because we don't have any favorable outcomes, and then the probability of an event that is certain, it's always going to happen, is 1, right? So if we thought about that as fractions, we could say, okay, well, that first case is 0 out of 6. That second case is 6 out of 6, okay? Like the probability of rolling a 7 on a 1 to 6 standard die is 0 out of 6, right? Of the 6 sides, 0 are a 7. The probability of rolling a number 1 through 6 on a standard 6-sided die is 6 out of 6. So that is a certain event. We know we're going to do that, and that probability 6 out of 6 is equal to 1. Okay, so the sum of all possible outcomes for a situation also is going to equal 1. So if we had the die example, we would have 1, 6 plus 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 1, 6, right? That would equal 6 out of 6. That's equaling our 1. Okay, so odds and probability, as I said, are often used interchangeably in everyday language, but it's important that we understand the difference between them. Odd statements are not written as fractions between 0 and 1 and are instead written as an actual ratio. Okay, these ratios can be written as, if we're talking about odds in favor, we want the favorable events first, and then the ratio symbol to the not favorable. And if we're talking about odds against, then the not favorable are going to come first, and then the favorable are going to come second. Okay, so we'll do through some examples of that, and hopefully if you've never seen that before, it'll start to make sense. So in those odd statements, the sum of the two numbers must equal the number of outcomes. So let's say you want the odds of rolling a 1 on that 1 to 6 day, okay? The odds in favor of that thing is 1, right? Because one of your outcomes is that 1. And then the other 5 outcomes are your non-favorable outcomes. So this is the favorable outcome, the 1, and then this is the non-favorable outcome, the 2, 3, 4, 5, and 6. Okay, so see how the sum of those two numbers in this case is 6, and that is the number of outcomes. You have 6 outcomes on that standard die. We're going to need to be comfortable with converting between odds and probability statements, and we'll practice that a bunch. So we're going to go through a ton of examples to hopefully get you guys familiar with this. So example 1, you're asked to spin an equally divided red, yellow, green spinner. Okay, so equally divided is important because that means you've got a third of a chance for each. If it's not equally divided, and we'll look at that at the next example, then things have to change a little bit. Okay, so we're doing that equally divided red, yellow, green spinner, and then roll a standard 6-sided die. Okay, so we're going to determine the outcomes, all of them, using the table. So we could make this over here, kind of our 3 rows, is representing our color. So we could use red, and then yellow, and then green. And then our rows could be the number that we roll. Okay, so we could do a 1, a 1, and a 1. And then a 2, a 2, and a 2. Red, yellow, green. See how, so that pattern is going to evolve, so we could have a red 3, a red 4, a red 5, and a red 6. We have a yellow 3, a yellow 4, a yellow 5, and a yellow 6. And then same thing for green. So those are all of our possible outcomes. Notice how we've got 6 times 3, so there's 18 possible, right? So total, just make a little note for ourselves, is 18. So if we want to find the following probabilities, we're going to look at how many of the total 18 options satisfy these specific criteria. So for this first one, we've got red intersect. Remember the upside down little U thing means intersect, so this means and. So it has to be both red and 4. So the only spot on our chart that is red and 4 is here, right? So that just is 1 out of 18 as a probability. And so we can leave that as a fraction. It's already reduced. That's perfect. The probability of a primary color and, so again, this is an and. So that's an intersect. Primary colors, remember, are red, blue, and yellow. Okay, so red and yellow are the options. Green can be made from blue and yellow, which are primaries, so it is not primary. Okay, so you could take red, yellow, and blue and make all the colors in the rainbow. Then even, obviously that's 2, 4, and 6. Okay, so we want a primary color and it to be even. So there's a few different options for this. So it could be red, and then we could have 2, right? Or 4 or 6. Or it could be yellow, 2, 4, or 6. So that's 1, 2, 3, 4, 5, 6 options out of the 18 possible. Okay, and then we're going to reduce that fraction because we should always be reducing our fraction. So that's 1/3. Okay, now we're looking at the probability of, we've got 2 conditional statements here. So we have red, union, green. Remember that union is kind of like or. So red or green intersecting with and a prime number. So remember, prime numbers are anything that only, the only factors are 1 and itself. So 1, 2, 3, 4 you can get to by doing 2 times 2, so that's not a prime number. 5 and then 6 you can get to by doing 2 times 3, so again, not a prime number. Okay, so we want red or green, so you can have red or green. 1 is going to be an option, 2 is going to be an option, 3 is going to be an option, and 5 is going to be an option. Okay, so red or green, 1, 2, 3, or 5. So 1, 2, 3, 4, 5, 6, 7, 8 different options satisfy that criteria. So 8 out of 18, and again, we're going to reduce. So those are both divisible by 2, so 4 out of 9. Okay, so then probability of yellow intersect factor of 8. So factors of 8 are 1, 2, 4, and 8. 8 obviously we can't roll, but it's still a factor of 8. So yellow and a factor of 8. So 1, 2, and 4. So that would give us 3 out of the 18 possible outcomes are those outcomes. So we're going to reduce that again. So we're going to have 1/6. Then the last one, we've got the probability of red complement. So remember that this means the complement if we have that little apostrophe. So basically that means that it's either yellow or green. It's anything that is not red. And then the complement, again, of even would be the opposite of that. So it's anything that's not even. So those would be the odd numbers, 1, 3, and 5. Okay, so we want yellow, and again, this guy means and. So we want yellow or green and 1, 3, or 5. So yellow and green, 1, 3, 5. So 1, 2, 3, 4, 5, 6 possible outcomes make that statement work. So 6 out of 18, that's again going to reduce to 1/3. Okay, so you can use a chart like that to organize your thinking, and it will help you. You can also use in the notes in the Snapbook, it also goes over tree diagrams. So that would also be a good way to do this, right? We could do a tree diagram where we had, we could roll a 1 and get a red, a yellow, or a green. We could roll a 2 and get a red, a yellow, or a green, right? So a different way to represent the same kind of information is what we did in the table. Okay, this next example, good thing my printer at home has color because otherwise this would be very difficult. I will really try to remember to make sure that whatever spinners or anything like that, I either like make sure they're labeled, so I could put like green, red, and blue in words, but I forgot and I printed them already, so here we are. But you guys can see it here and then just look at yours. Maybe write these for yourself so that if you're ever referring back to your notes and get confused about the 3 different shades of gray you have, write this as red, green, and blue. Okay, but thankfully we can see it here. So the probability of red, okay? So notice how there's a bigger chance that it's gonna land on red. We can just logic this out. We're smart humans. We can look at this and say, okay, it's more likely that the spinner is gonna land on red than it is on blue, right? Because a bigger chunk of the spinner is red than blue or green, okay? So the probability of red, we're gonna do this in terms of degrees, okay? So there's 360 different degrees. Remember, a degree is that like little tiny segment, right? So there's 360 all the way around the circle, right? So that whole rotation would be 360 degrees. Of those 360, 180 degrees are favorable. They're the red, okay? So that's the outcome that we want. Degrees and degrees kind of cancel, and so probability is never going to have a unit. It's just going to be expressed as a fraction. If we reduce this, this is going to be 1/2, and we can see that, right? There's a 50% chance that it's going to land on red, okay? If we're talking the probability of green, same deal. We're going to do 120 degrees of the possible 360 degrees is our green favorable. So then when we reduce that, we can do 120 divided by 360 reduces to 1/3. And again, we can see that, right? Like if there's 1/3, right? We can kind of divide this into sixths and then use our fraction skills. That is 1/3 of that spinner, okay? If we're talking about the probability of red or blue, we're gonna do 60 degrees for blue plus 180 degrees for red, and then divided by 360. So this is going to be 180 plus 60 is 240. And when you reduce that, we're going to get 2 out of 3. Okay, so the probability of red or blue is going to be 2 out of 3. Okay, so because these were nice easy angles, we could kind of turn it into like a little 6 options, right? 3 of the options are red, 1 of them's blue, 2 of them's green, and we can really logic out these answers that way. This degree method is always going to work even if it's not like a perfect 1/6 or 1/5 or anything that's familiar to us. So this is a better option if you ever have probabilities of a spinner and it gives you degrees. Okay, our next example is Edwin, I'm going to butcher his name, I don't know how to say it, Encarnacion, I think it is, I don't know, was one of the Toronto Blue Jays top hitters. His batting average one year was a .263. Okay, so that means we can write it, I think it's easier to interpret as a percent or a fraction. So if we take this decimal and we turn it into a fraction, that's 263 over 1,000. So that means out of every 1,000 at-bats, 263 times he gets a hit where he gets on base. That's important, right? You got to get on base for it to count. Otherwise, you're out, okay? So we want to check if we can reduce that fraction. Remember, your calculator can help you do that. Type that in, hit math, fraction, make sure it doesn't, or math, and then at the top, you just math, enter, I think. If you don't know how to do that, ask me not when I'm recording a video, I suppose. This one doesn't reduce anymore, okay? The other option that we can do this is we can write it as a percent. So if we're converting from a decimal to a percent, we can move the decimal in places 2 spots to the right. So there's a 26.3% chance that he's going to get a hit on base, okay? Which is pretty good in the MLB. The next example is a 6-sided dice that is rolled. Okay, so far we've just been talking probabilities. Now we're going to start talking about odds and start converting between the two. So what are the odds of rolling a 4? Okay, so that is 1 favorable option out of 6 total options. The unfavorable probability is the 5 unfavorable options out of 6 total options. So if we want this as odds of rolling a 4, we're going to write this as 1 to 5. There's 1 good option for every 5 bad options. Okay? And we can get those numbers from here. Same sort of deal here. So a spinner is used as shown below. What are the odds of landing on the lightest area? I think the yellow will look the lightest. This one I remember. The one at the top I didn't. I don't know. But I think yellow will hopefully look the lightest on your sheet. If not, it's these two. Okay, so yellow, those guys. So the favorable probability here is 2 out of 5 spots are the ones that we want. Unfavorable are 3 out of 5. And then odds, okay, so for yellow, we have 2 favorable outcomes for every 3 unfavorable outcomes. Remember that we said that the numbers in an odd statement should add up to the total number of outcomes. So we see that here. So 2 plus 3 is 5. Okay, so next example, Kendra has a collection of various cereals. 5 of the cereals contain corn, 2 contain rice, and 4 contain oats. So if you ever need to organize your thoughts, if you don't want to read every time, you can go 5 corn, 2 rice, 4 oats, right? To kind of organize that. Without looking, she selects a box for breakfast. What are the odds that she will select a cereal containing oats? So this probability statement in favor is going to be something containing oats. And we're going to write that as a ratio to the things not oats. Okay, so in this case, the 4 contain oats. And then the corn and the rice are both not the favorable option. So 5 plus 2 is going to be 7. So there's 4 favorable outcomes for every 7 non-favorable outcomes. Okay, so it's not the probability, those are her odds. we'll talk in a second about, okay, how do we get to probability if we have odds or vice versa? Okay, we'll do a few more odds. So 11 poker chips are numbered consecutively 1 through 10 with 2 of them labeled 6. So we've got a 1, 2, 3, 4, 5, 2 6s, and then 7, 8, 9, 10. A chip is drawn at random. Find the odds of drawing a 6 and then find the odds against. Okay, so at the very start we said, okay, we can do odds for and odds against. So odds for, that means that we want, okay, we have the odds of getting what we want compared to the odds of not getting what we want. Okay, so that would be the 1, 2, 3, 4, 5, 6, 6, those are the ones that we want, and then 7, 8, 9, or 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 not favorable outcomes. So that's what we have here. Then we've got the odds against would be 9 to 2. So it's the opposite. We have 9 unfavorable outcomes to every 2 good ones. Okay. So if the probability of an event is 3/7, what are the odds that it will not occur? Okay, so here's where we're going to have some conversion here. So we have favorable is 3/7. Okay, so we could figure out then, so therefore, these 3 little dots, that means therefore, in case no one's ever told you that, are non-favorable. If we took the 7 possible outcomes, subtracted the 3 favorable, then that would give us 4 non-favorable outcomes. Okay, so if we're talking about will not occur, we want the odds against something. Okay, so we want the non-favorable outcomes first, so that's a 4, and then the favorable outcomes after. So for every 4 times you get something that you don't want, you're going to get 3 somethings that you do want. Your odds against are higher than what you want. Okay, so if the odds in favor of an event occurring are 7 to 5, what's the probability of the thing occurring or not occurring? Okay, so remember that this is not in fraction form yet. This means that we have 7 chances for the event to occur and 5 chances for this not to occur. So the total number of outcomes is going to be 5 plus 7, so 12. So the probability of the event occurring, again, these are odd in favor, so this one is the event occurring. We have 7 out of 12. And then not occurring, we have those other 5 out of 12. Okay, remember that the probability of the 2 separate events should add up to 1. So 7/12 and 5/12 equal 12/12, and that reduces to a 1. Okay, so that checks out with what we talked about earlier. Couple more examples. So if we have Justin places a bet on the New York Giants. Okay, so this is a very like real life example. If you guys ever go to like horse races or if you're betting on sports or anything, this is how they calculate how much you win. Okay, so the odds, so he's betting for the Giants to win. The odds are 2 to 3. Okay, so the first thing that we want to know, are the Giants expected to win? Okay, so because the Giants winning, so if this is like positive odds, it doesn't say odds against, the odds are 2 chances for the Giants to win and then 3 chances for the other people to win. Okay, so no, the Giants are not expected to win because the number of favorable outcomes is less than the non-favorable outcomes. Right, so there's their favorable outcomes. They've got 2 shots at winning for every 3 shots they have at not winning. Okay, if we think about this as a probability, anytime you see that italicized P and then something in brackets, by the way, hopefully we figured this out by now, but this is the probability of whatever situation here. Okay, so 2 plus 3 gives us the total number of outcomes. So 5, so we've got 2/5. Okay, so if we did that as a fraction, we have 40%. Okay, And again, so 2 plus 3 gave me that 5. Okay. Now we want to talk about, okay, if he bets $20 on that game, how much would he win if the Giants won? Okay, so you only win money back if the thing that you're betting on happens. Otherwise, it goes to paying the other people. But because his odds are 2 to 3, right, his good scenario has a lower likelihood than the bad scenario. Oops, you can't see where I'm pointing. He should get paid more than what he bets. Okay, so we're going to look at this. So if we talk about 2 to 3 odds, basically for every $2 bet, he gets a $3 payout. Okay, so if he bet $2 and they won, he would get an extra $3, so he would get $5 returned when he went to this, because he'd give his $20, he wouldn't have that anymore, or his $2. Simplify. So if he gave his $2, he bet his toonie, they won, they would owe him $3 extra plus the $2 that he bet originally, so he'd get $5 as a actual total back. So the original bet plus the payout would equal the 5. Okay, so for every $2 bet gets $3 payout. Okay, so in this case, he's betting 10 groups of $2, right? 20 is 10 groups of $2. So the $20 bet would get him 10 groups of the $3 payout. Pays out $30. Okay, so he would get $50 total back, right? Because he paid 20, they owe him 30 plus the original 20 that he bet, so he gets $50. It's pretty good. Okay, if the odds were the other way, so if he was betting on this team, he would get less than that. That would be for every $3 bet, he would get $2, right? Because they're, in this case, he's betting on the underdog, so he's going to get a bigger payout if it actually happens. Okay, the other way that you can think about this is you can think about this as, okay, he's got a 2/5 probability. Basically, if you multiply by the reciprocal of that on the bet, you're going to get what he's going to get back. So we multiply by 5/2, 20/5, or 20 times 5 is 100, divided by 2, so that's a $50. Okay, so that's what they're actually having to pay him out. So that encompasses that $20 bet and the $30 actual winnings. Okay, so he gets that $50 back. Okay, couple more examples. So in a group of 100 people, 50 have cancer and 50 are cancer-free. Of the people with cancer, it's determined that 10 of them were exposed to a certain risk factor. Of the people who are cancer-free, 2 of them were also exposed to that same risk factor. So what we want to know are, what are the odds of being cancer-free if you're exposed to the cancer risk factor? So if you're exposed to the cancer risk factor is what we're talking about here. Okay, so notice how 10 of the people who have cancer were exposed, and then 2 of them who didn't have cancer. So that means a total of 12 people were exposed. Okay, so again, odds, we want that ratio statement that's going to add to 12. So cancer-free, those 2 people who were exposed are cancer-free, and the 10 people who were exposed have cancer. So these are the odds of being cancer-free. This is the favorable outcome. And when we have an odd statement like this, remember in, I don't know, junior high, you started reducing ratios. That means for one person who's exposed and doesn't have it, 5 people who got exposed are gonna have it. Okay, so that's the reduced form of the ratio. The second thing that we want to look at is, what are the odds of being cancer-free if you're not exposed? So this is the flip side. Okay, so of the 50 who have cancer, 40 of them were not exposed, right? Because 10 of them were. And of the 50 who are cancer-free, 2 of them were exposed, so that means 48 were not exposed. Okay, so again, odds of being cancer-free, we want to list cancer-free first, 2, the people who are not cancer-free and were not exposed. Okay, so again, we can reduce that. These are both divisible by 8, so 6 to 5. So 6 people are cancer-free for every 5 people who have cancer if they're not exposed to that risk factor. Okay, this is the last one. So if we're planning a picnic and are very concerned about rain, so you've picked 2 dates that could be used. Okay. After researching past weather statistics, you discovered that the odds that it will rain on the first day are 7 to 13. So that's 7 rain, 13 non-rain. And then the odds that it will rain, okay, are 9 rain to 17 not rain. Okay, so we want to look at probabilities for this, right? We want the day with the lower probability of rain, the lower percent chance of rain, right? If we were just looking at the weather app like a normal person instead of trying to calculate ourselves, we would pick the day that is less likely to rain. So we have to calculate that. Okay, so for the 7 to 13 ratio, that means that there's 20 total outcomes, right? There's 7 outcomes where it rains and 13 outcomes where it doesn't rain. Okay, so then the probability of rain would be 7 out of 20. Okay, and so we can that's our first stat. Okay, I'm going to convert that to a percentage because I just find percentages are easier to compare than fractions. So this is going to be 35%. For the 9 to 17 ratio, that means we have 9 days of rain for 17 or like 9 chances of rain for 17 chances of not rain. So 17 plus 9 is going to be 26. So we have 9 out of 26 total. Okay. Oops. So yeah, oops. I got ahead of myself. We have 26 total, so 9 days out of, or 9 options of rain out of 26 total options. When we convert that to a percentage, we get 34.6%. Okay, so again, we want the lower percentage. So you're gonna pick this day. They're so close though, so it's kind of a bit of a crapshoot if you ask me. But this one is 0.4% better, so we'll pick it. For practice today, you guys can read the lesson on page 88 to 94. So just some different examples, different wording of things, of what we talked about today. And then you guys are going to do numbers 1 to 16 on pages 95 to 97. Okay. So this only took about half an hour. So theoretically, you have about an hour and a half left in this block. So if you're done, and please do read this, like the more you see different wordings of it, different explanations of it, the better off you're gonna be. There's more examples before you do the practice problems. If you're done all of that, then you can be working on either your project or you can be working on any logic puzzles that you still have undone. Okay, I'll give you some more of those later this week when you guys have a whole day to focus on that. Okay, if you have any questions, let me know. Hopefully all of that made sense.